Today we're going to be classifying rational and irrational numbers and also talking about ordering numbers. So go ahead and get out a piece of paper, get a pencil, a pen, a calculator, and be ready to go ahead and take some notes. First of all, we need to go ahead and we need to talk about the definition of different numbers. So first of all, we're looking at the natural numbers. Natural numbers are known as counting numbers. So what do I mean by counting numbers? Counting numbers are numbers that we can physically count, kind of like in kindergarten. So 1, 2, 3, 4, 5. So if we want to go ahead and have some examples of counting numbers, so 3 is an example, 256 is an example, 1000 is an example of counting numbers. Next, we're going to be going ahead and talking about whole numbers. Whole numbers are counting numbers, but along with 0. The only difference between whole numbers and counting numbers, it just has 0 to go ahead and go along with it. Next, we're going to be talking about integers. Integers are positive and negative whole numbers. So positive and negative. So example of integer, we can say the integer is like -5, -16, positive 56, and positive 105. Okay, so these are examples of positive and negative whole numbers. Next, we're going to go ahead and talk about rational numbers. Rational numbers, they actually have 3 definitions that go along with it. The first one, so the first definition is fractions. So again, we know what fractions are. So a great example of fraction is 3/4, 7/10. Okay, so fractions. The next definition for rational numbers is decimals that stop. So an example of decimals that stop is 1.5, 4.7. Okay, so decimals that stop. And then the last definition for rational numbers are decimals that repeat. So example of decimals that repeat are 4.3 repeated, 10.6 repeated. Okay, so these are decimals that repeat. The last definition that we need to go ahead and talk about is irrational numbers. Irrational numbers are numbers that never stop and never repeat. So they're kind of like decimals that never stop and never repeat. So a great example, the famous example of irrational numbers is pi, because we know that that number goes on forever and ever and ever. So this is a great example of irrational numbers. So the way for us to go ahead and define a number and kind of classify a number with the information is kind of this pool effect. Okay, so when you throw a rock into a pool, it makes ripples. So it's kind of like this ripple effect. So here we have natural, whole, integer, rational, and then we have the other numbers over here, which are examples of irrational numbers. So if I wanted to go ahead and I wanted to classify a number, so let's say we're going to go ahead and we are going to classify the number 5. So let's think about a 5 is, let's look at the smaller circle. So the smaller circle is natural. So is 5 a natural number? Yes. So what I'm going to do is I'm going to take and I'm going to put 5 into that ripple, and then we're going to talk about what other ripples do I need to walk out of to get out of the pool. So we know that 5 is natural. What other ripple did I have to walk out of? I had to walk out of whole. And then I had to walk out of integer. And then I need to walk out of rational. So 5 is classified as natural, whole, integer, rational. So let's look at -2. So is -2, let's go ahead and try to put in one of the ripples. Is it natural? Is it a counting number? Well, no, it's not a counting number. Is it 0 plus a counting number? Well, no, it's not. Is it a positive or negative whole number? Well, yeah, it is. So let's put -2 into that ripple. And then what ripples do I need to walk out of? Well, we walk out this way. Either way, actually. So we know it's an integer. And we know that it is rational. And then what numbers can we put into the irrational area? Okay. And if we, so we know we talked about the number pi. Okay, it goes on forever. And then what other numbers can we put in there? Well, we can put in square roots that are kind of go on forever and ever and ever and ever. So an example of a square root that goes on forever, let's talk about square root of 2. Square root of 2, if you put it into your calculator, it goes 1.414213562, and the screen of the calculator ends that decimal, but it actually goes on forever. If we did it by hand, it would go on forever and ever and ever and ever and ever. So the square roots, if you put them in your calculator, it does not come back as a whole number. It comes back as a decimal. It's considered irrational. So here we have some practice problems. Go ahead and grab a piece of paper, write them down, write down the classification of each of them so you can know if you're doing them correctly or not. And you can go ahead and pause the video and to make sure you are doing it correctly. And then here we have the answers to our practice problems. So first of all, we're looking at 1/2. So 1/2 is a fraction, so we know that. So it's just going to be rational. Next is 8. 8 we know can be a counting number. So if we look at it, it is a natural number, a whole number, an integer, and rational. Number 3, we're looking at -12. -12, is that a counting number? No. So I can't count it like I was in kindergarten. So we kind of go along the ripples and different things. 12 is integer and rational. Number 4, we have 6.25. This is a decimal, and it does actually stop. So this one will be considered rational, just rational. That's all it is. Number 5 is square root of 5. So if we take square root of 5, we put it in our calculator, we get this big, long decimal. Now remember that our calculators kind of cut it off because that's how big our screen is. But if we actually did it by hand, this would actually go on forever and ever and ever. Okay, what kind of number is that? It is irrational. Number 6, so remember with number 6, we have the 0.318, okay? So remember that this line here tells us that this decimal is a repeating decimal. And what repeats? The 318, 318, 318. So this is a repeating decimal. So if it's a repeating decimal, then it's just rational. Number 7, we have square root of 4. Take square root of 4, put it in your calculator, press enter, and you're going to get 2. So this is a little bit different. So the answer to square root of 4 is 2. Now we need to go ahead and classify this number. And number 2 is considered a counting number, so it's natural, whole, integer, and rational. Next, we are going to go ahead and order some numbers. So here we have a list of numbers. So we have square root of 2, 1.4, 1.4 repeated, 1.04 repeated, and then pi over 3. What we want to do is we want to go ahead and put all of these numbers in decimal form. So if we go ahead and do the square root of 2, we're going to write down not all of the decimal points, but just some of them. Square root of 2, if you put it in your calculator, we have 1.414213, and it kind of keeps on going. 1.4 is just 1.4. And then if we look at it, now we have 1.4 repeated. So remember that number is going to be 1.444, kind of keep on going on. The next one is 1.0444, keeps on going on. And then we're going to do pi divided by 3. We're going to put that into our calculator. and we get 1.04179, and then it keeps on going. So now looking at the decimals, we want to go ahead and put them from least to greatest. And if we do from least to greatest, we want to go ahead and compare them. So we have here 1.04, but then we have 1.047. So first of all, it's going to be this one. And when we go to write the answers down, we're going to write the answers in the original number. So the first one is going to be 1.04 repeated. And then I like to kind of cross them out to kind of remind me, hey, I've already done them. Then we're going to be doing pi divided by 3. And then cross it out because we've already kind of compared those two. And then now we can go ahead and compare what we have left. Well, what do we have left? We have 1.414, 1.4, and then 1.4444. Okay, so which one is going to come first? Well, this one is, because it's really, if you look at it, it's 1.4 and then like 0, right? Remember that? So we're going to have just 1.4 is next. Okay, and then what is next after 1.4? Well, what do we have left over? We have the square root of 2, which is 1.414, and then we have 1.444. So which one comes first? That would be the square root of 2. And then the last one, okay, cross it out. And then the last one is 1.4 being repeated. So we've taken all these numbers and we've put them in order from least to greatest. But again, we put them in decimal form first, compare them, and then we write down the original after. So let's look at the second example here. So we have 3.14 repeated. We have pi, 3.14 is just being repeated, 3.14, and then 3. So again, we want to go ahead and we want to put all these numbers into their decimal form. And the first one is going to be 3.1414, kind of keep on going. If you put pi in your calculator, you're going to have 3.14159. Okay, keeps on going. Next, we have 3.1, and then the 4 is being repeated. And then the other two are decimals that stop. So let's go ahead and let's compare them. Which one is the smallest from least to greatest? Well, that's going to be just the 3. So we're going to put 3 first, cross it out, and then what do we have next? So we have the 3.1414, 3.14159, 3.1444, and then 3.14, and then remember there's a 0 after that. So which one is the smallest after that? After the 3 is 3.14. Okay, then let's go back. Let's compare what we have left. What is after the 3.14? Well, we are going to have these. So if we look at closer at them, we have 3.141. We have 141. Okay, 1414, 1415. And then 1444. So if we come back down to these two, this one's going to be smaller. So let's write it down. So it's 3.14 being repeated. Okay, let's go back down to where it last two. We have 3.14159. Keep on repeating. Then we have 3.144. Which one is next? Well, the next one is going to be pi, and then the last one is going to be 3.14 repeated. Okay, so these are going to be our answers. Again, we write the numbers how they originally were, so we take them, we put them in decimal form, but then we go ahead and write them how they originally are. Here are some practice problems for you. Go ahead and write them down, and if you want to pause the video, you can, and you can go ahead and put them in order, and then I'll show you what the answers are. So number 1, your answer should be here. And then number 2, your answer is here. So hopefully you've learned how to go ahead and order numbers from least to greatest. Remember that you want to go ahead and put the numbers in decimal form, and then when you write them down, you're going to write the original number that was given to you. Have a great day.